Welcome, everyone. This flipped classroom video is going to focus on stoichiometry involving Avogadro's number. So far we've started by discussing stoichiometry involving molar mass. And these are probably the most common type of stoichiometry problems just because mass is so easy for chemists to determine using a balance. But sometimes we're asked different variations of this concept, and that's what we're going to focus on today. And today we're going to use Avogadro's number. Remember, that's at 6.02 times 10 to the 23rd we talked about earlier this year. And Avogadro's number can be used to compare the number of particles, which could be either molecules, atoms, ions, or donuts, to moles of the same substance. Just like before, the only way we can go from one substance to another is using the mole ratio. All the other conversion factors require that we stay with the same substance, just changing its units. So let's go ahead and try this out with a problem. If I have 27 grams of methane, CH4, that combusts with excess oxygen, how many molecules of water are produced? Okay, so when I read through this, I want to look for my given and what I'm trying to find. So in this case, my given is my 27 grams of methane. So I'm going to go ahead and underline that. And then I want to circle the thing I'm trying to find, which in this case is the molecules of water. Now, I'm also told that this reaction is a combustion reaction. It says it right in the statement. And then I have excess oxygen. So if I think about combustion reactions, that's when I have a hydrocarbon plus oxygen, and I always get the same two products, CO2 and H2O. Now, once I have my basic equation, I want to go ahead and balance it. So if I look, I'm going to need a 2 in front of my water to balance out my hydrogen, and then a 2 in front of my oxygen to balance out my oxygen. So that is step one of any stoichiometry problem, get that balanced chemical equation. After I've done that, I'm going to take my given, which in this case is in grams, which we know how to work with, and I want to get into moles of my given. So I want to go from grams of methane to moles of methane. So for this, I'm going to need to set up a factor label table. Now, just like before, if I have grams of methane on top, on the diagonal, I need the exact same unit because they need to be able to cancel out. So I'm going to have grams of methane up top. And step 2 tells me I want to go to moles of my methane. So I'm going to go right up above. And this vertical column here, the moles and the grams, that's going to be my molar mass. But I'll come back to that in a little bit. On my next diagonal, I'm going to start to do my molar ratio. So I'm going to have moles of methane on the bottom. Remember, mole ratio compares moles of one thing to moles of the other by using the coefficients from the balanced chemical equation. So I'm going to have moles of water up on top because that's the thing I'm trying to find out about. Again, on the diagonal, I copy and paste that exact same thing, moles of water and moles of water, because I need them to cancel out. And then up on top, I'm going to go ahead and put the unit I'm trying to find, which is going to be the molecules of water. Now I'm going to go back and fill in my numbers from here. For the molar mass of methane, I'm going to add up the mass of 1 carbon and 4 hydrogen, which ends up being about 16.05. And I know molar mass is always grams per 1 mole, so 1's going to go up on top. Now for my mole ratio, I want to look at the coefficients for my balanced chemical equation. If I look for my methane, I see there's not a coefficient there, so I know it must be that invisible 1. And then the coefficient for my water is the 2, so that's going to go up on top. Now, if I have moles of water up on top in the denominator on that next diagonal, I'm still just going to have 1, okay? Because remember, we're talking about moles to Avogadro's number in this case, and moles to Avogadro's number, we always have 1 mole. So Avogadro's number, that's 6.02 times 10 to the 23rd is going to go up on top. So across the top, remember I multiply, on the bottom I divide. And just a handy little tip, remember when putting scientific notation in your calculator, you have to be very careful. So how I put Avogadro's number in, I type 6.02, and then I look for that second button. On my calculator, it's blue, but it's going to be in that top left-hand corner. You press that, and then you're looking for the EE button, which is going to kind of be hidden underneath the comma. So you press the EE, and then you type 23. And that's how you want to put that scientific notation number into your calculator so you get the correct number of multiplication factors. So if we go ahead and put this all in, we're going to end up with 2.0 times 10 to the 24th molecules of water. Now in this case, we need 2 sig figs because we started off with 27 that has 2 sig figs. My 2.0 does give me 2 sig figs. Remember, trailing zeros are significant if there's a decimal point, and the times 10 to the 24th, that doesn't count towards my sig figs, so I'm all good there. Okay, so let's go ahead and have you try a problem now. How many oxygen molecules are needed to completely burn 27 grams of methane, CH4? Okay, so start by writing out that balanced chemical equation, then go from your given to the moles of the given, use your mole ratio, and then finally go from the moles of your final thing to the unit you're being asked to find, which in this case is molecules. So go ahead, try it out yourself, and I will see you in class. Thanks for watching.